Greetings, everyone. This is Chris Almond with IBM. I have been invited to meet with everyone here today and talk about a really interesting topic. We gave the title of this presentation a catchy name, Virtualize This. And it's really all about the case for running virtualization on top of Kubernetes and specifically on top of OpenShift. So it's actually quite a meaty topic. Today, we're just going to do a high-level conceptual introduction, and by the end of this presentation, what I really want you all to be able to do is just understand rationale for when you want to use virtualization within OpenShift and why you would want to do it. So we're just going to press on into the slide deck now, and I believe my slide is now showing in the meeting room. Correct? All right, we'll move on here. Okay, so I want to start with a thought exercise. And the way to do this first, I'm grabbing a picture from the Kubernetes.io documentation site. This is the picture that they put at the top of the very first page of the Kubernetes documentation site, where they explain the kind of where Kubernetes came from. Looking back in time is the way they caption this picture. And I just want you to focus on the middle and the right-hand part, the virtualized deployment, the container deployment. And when we go through this thought exercise, I'll talk more about it. The first thing I want you all to understand, and I'm maybe reinforcing things you all know, but you may not. So containers are not VMs. If you see the container runtime box in the third layer up on the right, you can almost think of that as just a set of features that have been turned on that extend the capability of the operating system. It's really one box here. The operating system is being extended with kernel-level features that implement a container runtime. All right. Whereas in the middle, the operating system and the hypervisor together provide a different kind of service. The hypervisor could be decoupled from the operating system, or it could be one and the same as well. So there are some nuances there in between. But the key thing here is just to realize that a virtual machine and a container are different. Container is all about process isolation inside the operating system, whereas a virtual machine is all about encapsulation of an entire other operating system and provide that runtime environment via the hypervisor on top of an underlying operating system. Okay, so containers are not VMs. However, a VM can be run inside of a container. All right, so this is the first part where you have to twist your kind of perception a little bit and go, wait a minute, why are we going back in time and now flipping things around and putting VMs inside of containers? Well, technically, because it's possible, but there's also great reasons to do it, which is really the gist of this presentation today. I highlight changing one of these apps over here on the container runtime side to what we call a KubeVirt container. And notice inside there's some machinery, LiveVirt, QEMU, and an internalized KVM hypervisor layer. And that combined with an image of an entire virtual machine is now actually running within a container runtime process isolation instead of as an entire virtual machine running on top of a hypervisor. All right. Now, on to the next level. Now let's think about Kubernetes. Beforehand, I'm talking about it as just hardware. You notice down the bottom right there, I'm calling it a Kubernetes node now. And I'm introducing the concept of a pod, right? So a pod is really the atomic unit of orchestration within Kubernetes. Kubernetes controls the state of one or more pods, actually lots of pods, across clusters of pooled compute capacity, all right? That might sound familiar to you, though, you guys, from the VMware and virtual machine operations world, where you cluster a group of machines together, all running a integrated hypervisor, and then you're also pooling those same resources, and you're orchestrating the lifecycle of entire virtual machines across that pooled resource. Well, Kubernetes abstracts that in a different way with respect to pods instead of VMs. But again, we can run one of those VMs entirely inside of an orchestrated pod in a Kubernetes environment. All right. Now, like I said, Kubernetes is going to orchestrate the life cycle of those pods. Okay, so let's make a statement. Therefore, Kubernetes can orchestrate the life cycle of pods, and they can run containerized VMs inside of these KubeVirt containers. So All of this thought exercise gets you to the point where, oh, I see how this is technically possible, but you may be still asking yourself, why would I want to do this? Well, if you think about the machinery that's facilitating this capability, then you move yourself into the frame of reference of, what if I really want to containerize everything as much as possible, run it in Kubernetes, but then I still need to run a few VMs here and there? Then all of this starts to make sense. And I'll illustrate that more as we go through the deck. Okay, so let's move on and ask that question and go deep on it. Why use Kubernetes to host VMs when traditional hypervisors are already very good at it? Now, recently, as in last month, and we're recording this here in July 2023, and 3 weeks ago, toward the end of June, our friends at the Cloud Native Compute Foundation hosted a webinar. They host plenty of these, and they're excellent. The recording is now available on YouTube for you to review. And I'm grabbing a screenshot of one of the slides that our friends at Spectral Cloud presented as part of this presentation. The presentation was titled, Making VMs a First-Class Citizen in Kubernetes with KubeVirt. So again, very closely, pretty much 100% aligned with the gist of this presentation. But notice they're pointing out reasons why VMs in general are here to stay, yet this is still a very compelling operating model to pursue. And I'm going to illustrate kind of more detail some of the key points here. On the left, this is all about how do we transition apps and services that do not easily translate into containers. Containerization, it's a challenge. It's not easy sometimes to decompose a complex application stack, refactor it, and rebuild it from scratch in a microservices-oriented way, where everything, or as much as possible, everything is declarative and able to be restarted at a moment's notice. In some cases, it's possible. In many other cases, it's just not feasible due to maybe not technical issues, maybe it's licensing issues, or maybe it's security concerns. But nonetheless, transitioning apps and services that do not easily translate into Kubernetes or into containers, but still run them on Kubernetes is an important driver behind this trend. Okay, over here on the right, they make the point about consolidation and shared resources and siloed teams and unified operations security. Great goals to always have in mind in your operations environment. And really what this boils down to is being able to schedule, connect to, and consume VM resources in cluster as if they were container native anyway. This is actually a huge win when you start moving VMs into containers inside the Kubernetes environment itself. And then in the middle, I'll comment on this. It would be kind of premature and outside of my purview to say anything about this upcoming acquisition with Broadcom and VMware. However, they may make a valid point about the cost of the hypervisor. And it is definitely going to happen sooner or later that once the majority of workloads are running on Kubernetes in your environment, then the CapEx, OpEx equation, as I call it, will start tilting toward bare metal as a more cost-efficient, probably more secure, more easy to operate environment, less attack surface area, less complexity, less entropy, et cetera, et cetera. So again, this is a review of why would we want to use Kubernetes host VMs to begin with, and I'm illustrating 3 different concerns that a lot of people are starting to think about right now and very frequently. All right, let's move on. What makes Kubernetes good at running VMs? Notice the previous question was why, but okay, we get the why, but how does Kubernetes do this in a way that makes it feasible and enterprise grade? Okay, so think about clustering and a cluster of hypervisors, which you may be very familiar with. Now, Kubernetes really pioneered a different way of abstracting compute nodes into a single pool of compute capacity. Right, and kudos to the pioneers in the virtualization space, especially VMware, in introducing this capability a couple decades ago now, and in particular, highly available clustered virtual machine mobility with the dynamic resource scheduler and things like that. At Kubernetes, the machinery in Kubernetes solves the same problem in a different way for a different use case. Primarily, it's for the orchestration of pod lifecycle, where everything that's running can be started up again quickly at a moment's notice and in an API-driven fashion, because it's all declarative. And you've done a great job of separating ephemeral from persistent operating concerns and workloads. And you've done a great job, again, at containerization, which means breaking things down into do one thing, do it well, and if you need to do something else and combine it in your stack, you do it in a separate container, in a separate pod definition, right? So the Kubernetes scheduler is smart enough to choose which nodes to run pods on based on current resource consumption. Just like in a clustered virtualization environment, you would expect, especially with dynamic resource scheduling turned on, that your cluster manager would be smart enough to know which host to put that virtual machine on, and maybe which host to migrate that virtual machine to, depending upon workload patterns across the nodes in the cluster. Kubernetes provides that same capability, but what we're moving around is pods, which again, as a result of the previous thought exercise, can also be thought of as containing entire VMs themselves, right? So the orchestration engine underneath Kubernetes can, and in some cases should be used for orchestrating the lifecycle of VM too. Should be, for all the reasons I talked about in the previous slide. All right. Okay, let's move on. So now I'm going to transition. We talked about Kubernetes and virtualization in general. Now let's talk about OpenShift. I am an IBMer. I'm actually an ex-Red Hatter too. And I bring this perspective into this discussion, and it helps me understand how IBM and Red Hat together are creating by far the most powerful hosting platform for Kubernetes-based application management. And all of you are probably already very familiar with what OpenShift is and where it's positioned in the market. Reading these bullets off is kind of a really good thing to do right at this point, just to make sure you guys get this. It's stable, enterprise grade, and it provides VM hosting capabilities too, which is different in my experience than any of the other major on-prem Kubernetes solution vendors today. They may be able to say, yes, we can set up Kubernetes virtualization and support it on top of our Kubernetes distribution. But you're not going to see any other Kubernetes solution providers today that provide an integrated virtualization management experience reflected in the picture on the screen in the UI. Notice I'm highlighting the virtualization menu item on the left. And in the middle there, you actually see a list of virtual machines. But this is within the context of the Red Hat OpenShift container platform. All right. So, and again, it's a Red Hat engineered open source platform, which means you are entitled with your Red Hat OpenShift subscriptions to full support for this capability as well. All right. So if we double click in here a little bit, notice I put the red circle around that create button in the middle right there. I expanded that portion of the screen a little bit. What pops up? Well, let's create a virtual machine. We can do it with a wizard. We can do it with the YAML. We can use an import wizard. We can source different virtual machine templates. It's interesting that we're breaking out with wizard, with YAML. This is kind of the way things work in the Kubernetes and OpenShift world. You want to provide declarative API and code-based ways of doing everything that you would also do in the UI. And so, Red Hat has engineered this capability in the OpenShift platform to kind of adhere to that general principle around everything you want to do in Kubernetes, make it CLI and API addressable, as well as providing extra capabilities via UI. All right, so let's go a little bit deeper on this. We're creating a virtual machine. And we're also providing, as you can see here from these screenshots, a mature VM lifecycle management capability. Again, integrated directly into the OpenShift console environment with the underlying tooling that's provided by the operators when you enable the OpenShift virtualization service in your existing OpenShift clusters. All right, I'm going to click in again. So one more thing about making OpenShift great at running VMs, and that is under the covers, there's a tremendous amount of engineering and development within IBM Red Hat and upstream across the community at large. The KubeVirt project is very active. And this all translates into a tightly coupled tool chain within the OpenShift environment. It is initialized when you enable virtualization in OpenShift by an operator. And the concept of an operator, it could be an entire breakout topic on its own for another seminar. But in a nutshell, what we're doing is we're saying, OpenShift, please spin up an operator, which is kind of like a virtualized person, if you will, that's going to go in and do all the care and feeding in a programmatically and deterministic way of the operation of this function within my OpenShift environment, or with my Kubernetes environment in general, because operators can be applied to any CNCF compliant Kubernetes cluster. All right. So we're utilizing an operator. It defines multiple custom resource definitions, config maps, and other Kubernetes resources to provide this type of virtual machine service catalog capability, and to spin up a Vert controller, and to provide the ability to do all kinds of advanced virtual machine management tasks on top of OpenShift. All right. Including taking into account scheduling, overcommitment, and high availability for those same VMs. All right, so I've kind of covered a lot here, and there's a lot more to cover, and I'm including a bunch of links here in the deck, so you can go out and take a look at the latest documentation about OpenShift Virtualization. There's a nice blog that's been written pretty recently about what's new. There's a live demo environment that's available at that demo.openshift.com URL. And just last April, IBM and Red Hat in partnership with AWS wrote a really helpful and kind of technically fresh blog about the benefits of running virtual machines on Red Hat OpenShift. It is, of course, focused on AWS customers. However, what they talk about in that blog is really applicable to any type of environment in which you want to run OpenShift and you want to turn on the OpenShift virtualization capability and use it. All right, so that's it for my presentation, and I really appreciate y'all joining me today. So I think my colleague Pete might want to jump in and add a few things.
Yeah, thanks, Chris. An awesome presentation. Hopefully everybody can hear me okay. If not, somebody please interrupt. But I just wanted to add a few comments onto the end here and really, I think, punctuate a lot of the things that Chris has talked about here today. First and foremost, we are going through a transition and a change in the industry right now. And there are very diverse needs, very different design requirements of these different solutions. So when you talk about VMs, virtual machines, they really were built to solve the problem of server sprawl, well over a decade, actually a couple of decades ago. And they're very good at solving that particular problem. Now comes along containers, and containers are meant to really solve the problem of delivering application agility. The concept is you essentially build your application out of microservices, and a single application could result in hundreds of potential microservices. So architecturally, these are two very different approaches, and each has pros and cons in terms of the heavyweightness of the applications, the operating system, the underlying infrastructure to support all of that. And what we're talking about here today, what Chris has talked to you about, is the ability to have an environment that can host all of that. As you progress and moving from virtual machines into more containerized applications, it's natural to think that you're going to have needs that you won't be able to transition all of those applications overnight into containerized applications. It's a 12-step process in doing that, and it can take time. With the approach that we're talking about here today, and many in the industry call this a platform approach, we're able to support the traditional legacy virtual machine environments while getting a path forward to these new containerized environments and all the benefits that containers bring around agility and speed and flexibility. So it's really this platform concept that is becoming more and more popular, the ability to have one singular environment to support these very diverse needs. I also want to remind everybody, and it looks like somebody already has put a question in the Q&A, but please do use the Q&A if you do have questions for us. So Chris, maybe what I'll do is I'll pitch this out to you verbally, and you can answer it, and then we'll also try to type the answers back in here too. So this one actually comes from an IBMer, Pooja, who we all know. And the question is, can we propose our clients to migrate from VMware to VMs to OpenShift Virtualization? Do we have as much maturity in OpenShift Virtualization technology as in VMware? So two-part question.
Yeah, I'll jump in on that. Is my audio still good?
Yes, it is.
Thank you, Pooja, for the question. I think I made it clear during the presentation that proposing to clients that you migrate VMs to OpenShift Virtualization is a valid, supported, and very capable way of solving a hard problem. However, it is incorrect and fundamentally not aligned with our strategy to say that OpenShift Virtualization is ever going to be as mature, mature is the key word here, as what VMware pioneered in their virtualization ecosystem. It's not the goal of our OpenShift Virtualization platform to ever approach that level of integrated machinery and tooling that is really designed to host VMs first. OpenShift is all about hosting containerized workloads in pods first. OpenShift Virtualization gives you an avenue toward pulling in certain virtualized workloads and make them cluster native. But it's not planned and will never, because it's built on Kubernetes itself, because of the underlying framework, it'll never be capable, nor would it be advisable to try to make Kubernetes behave like a standard vSphere cluster. That's not the goal. Does that help?
Yeah, and maybe to characterize it in a slightly different words is the goal is really to provide a transition path to this container native world. And the goal is to eliminate the need to have two different environments that you're supporting simultaneously. So you're absolutely right, Chris, in terms of the message is it's a transition tool for you that you can bring your VMs into OpenShift, and then you can migrate those applications to be truly container native and take advantage of all of the goodness that Kubernetes and OpenShift brings. That's really the approach here. It's not the approach where OpenShift will be the platform that will run your VMs forever and ever, and you'll have all of the features that you correctly pointed out, Chris, that VMware has baked into their tools. There's decades of development that has gone into those tools. And it is not the promise to deliver that kind of parity. It's more giving people a transition path. Excellent. Thanks for the question, Pooja. Any other questions from the audience? Doesn't look like it. So I think with that, we can probably call it a wrap.
Perfect. Thank you so much, Chris and Pete. You guys did a wonderful job today. This is just a few reminders for everyone in the audience. We will email you guys the on-demand recording and slides later on today. There will also be a link to connect directly with all of our experts from the IBM community. This concludes today's webinar. Thanks for joining us around the globe, and we hope you have a wonderful day.